Hello and welcome to the Titus Timeout podcast. Today's topic is, what are fan boxes and how do they work? We covered VAV boxes in the last video. Fan boxes are just another type of VAV box which, as the name says, has a fan. They're often referred to as powered induction units or PIUs. There are two types of fan boxes, series and parallel. Both types have the same basic components. Let's start with the series box. The series box consists of a casing. The casing has a supply air inlet, also called the primary air inlet, with a damper in it. There is also a discharge that is ducted to diffusers in the room or occupied space. The supply air inlet is ducted to a supply air handler. There is also an induced air inlet that is open to the ceiling plenum to bring in warm air when heating is needed. This can sometimes be ducted to the return air system and acts as free heating for the first stage of heat. The key difference between a series and parallel fan box is the location of the fan. If the fan is on the discharge, it is a series fan box. It is called a series fan box because the fan is in series with the primary air stream. So whether the air comes in from the supply air inlet or induced air inlet, it all goes through the fan. So let's move this out of the way a little bit. Now, a parallel box has all the same parts, but its fan is located on the induced air inlet, so it is parallel to the primary air inlet. It's usually mounted on a fan deck and has a backdraft damper. So you can see that the air that comes in through the primary air inlet never goes through the fan. Only induced air goes through the fan. I mentioned a backdraft damper in the parallel fan box. The backdraft damper is a gravity-operated damper that opens when the fan is blowing on it. When the fan is off, the damper is closed so the air supply cannot go out the induced air inlet into the plenum, wasting energy. This difference in fan location changes the pressure and sound performance of the two different types of fan boxes. Let's move this out of the way a little bit and let's look at the difference. Let's look at the operation of the series fan box first. Because all the air that comes into the box has to go through the fan is on all the time. The fan also has to be big enough to handle the maximum airflow that the box will see, typically the cooling airflow. On the positive side, because the fan is at the discharge of the box, it'll boost the air to the diffusers in the space. The supply air handler only has to be large enough to get the air into the box, and the fan box will do the rest of the work. Also, since the fan is on all the time, the airflow and sound level in the space is constant. Series fan boxes are sometimes called constant volume fan boxes for this reason. Now let's look at the parallel fan box operation. The fan is on the induced air inlet, so it only turns on when heat is needed. This means that the fan only needs to be big enough to handle the heating airflow. One disadvantage to having the fan on the induced air inlet is that the fan cannot help boost the air to the diffusers in the space. The supply air handler has to have higher pressure so that it can do that. Also, since the fan turns on and off, the airflow volume and sound in the space will vary, and this can be annoying to some people in some applications. For this reason, the parallel fan box is often called a variable volume or intermittent fan box. So now let's look at the operation of the two types of boxes using some actual airflow numbers. Let me get them drawn again real quick. In the series box, say you have 1,000 CFM at 55 degrees coming in the supply air inlet. This will go out the fan into the space at 1,000 CFM at about 55 degrees. And there's no airflow coming in the induced air inlet because your fan and your primary are balanced. Now let's say you need to go into heating and you drop your primary air to 300 CFM, again at 55 degrees. Because your fan's doing 1,000, you're pulling 700 from the ceiling plenum, which is warmer, about 75 degrees. When you do the math here, you find that you get about 1,000 CFM at 69 degrees in the space. Now let's do the same thing with the parallel fan box. Again, 1,000 CFM at 55 degrees in the supply In cooling only, gives you 1000 CFM at 55 degrees going to the space, with 0 CFM coming in through the fan. When you go into heating, you go back down to 300 CFM in your primary, but say you turn your fan on at 500 CFM at 75 degrees. When you do the math this time, you'll see that you have a 800 CFM at 68 degrees. So you can see the different types of fan boxes do basically the same thing, but with slight differences. Across the country, the use of series versus parallel is more or less split 50-50 depending on what state you live in, but strangely it's not driven by the climate of the state. And that's how fan boxes work. Thanks for taking a time out with us.